We really went to town there on those 3D graphics. Here with me in the studio, Dr. Simon Foster, solar physicist at Imperial College, who featured in that clip, and that was your colleague Martin Archer there speaking there, and it all looks utterly fascinating. So, come on, tell us, what would life be like on that spacecraft, gravity, etc.?
Well, when we first get into orbit around the Earth, you'd be weightless, as you probably saw in the clip there. We're floating around. But what we're going to do on our way to Mars, we'd actually recreate gravity, or we'd cause some artificial gravity to happen by spinning the kind of ship around. And in this way, it prevent our muscles wasting along the way. The real problem you're going to probably have along the journey is boredom, in many ways, because you're going to be stuck with 3 people all the way on your journey, and that could possibly, in many ways, be the big issue that's going to be on a mission like this.
You know, isn't it funny? We've just done that whole discussion on Shakespeare and taking Hamlet around the world and being stuck with 12 people in 205 countries, and yet I would imagine the problems are identical in terms of what it would be like to go to Mars, 3 people cooped up together, very confined space for that long.
Yeah, I was going to say, there's been an idea of sending a mission there in 2018, a guy called Dennis Tito, who was the first space tourist. And he's had the idea of sending a married couple because hopefully after surviving, you could say, 20 or 30 or even 40 years of marriage, that they should get on well enough that they could survive a 500-day voyage to Mars and back.
Yeah, and so how do you all kind of get along with each other? Is it just about the people you select?
Yeah, I would say there's going to be a lot of kind of psychological tests. That's probably going to be the biggest thing that's going along here. I would say it might be worth sending people from different nations, because that way you've got a completely different background, so everyone can talk. Does that make sense? You would have grown up in completely different situations. You also might have the possibility to learn different languages, which at least that way you're learning something along the way.
And I just want to ask the very practical questions. What do you eat? What do you drink?
Food will be taken with you, so that's going to be ration packs. They're not going to be particularly nice. That was a big problem on the Apollo missions. There was nearly some kind of revolutions over that, because basically the food is going to be quite terrible. The drinking is going to be recycled from basically urine. So on the International Space Station, they've got...
yeah. I don't want to dwell on it, but I do want to dwell on it. Hang on. The only liquids aboard would be recycled urine?
Yeah, well, because if you think about it, it costs a fortune to send, I think it's anywhere between $15,000 to $20,000 to send a kilogram into space. So that's a litre of water. That means it's not practical or even cost-effective to send enough water for your entire journey. So you've got to reuse what you've got. And the easiest way is reusing your urine and making sure you filter that properly and drink it.
OK, well, one interesting thought that we had was, what if someone gets sick? You can't exactly go to A&E, can you now? Well, we're actually going to play one more clip from the virtual craft simulation experience.
All along our journey, our vital statistics are going to be monitored, but occasionally someone will get ill. Up here, we're going to have to solve this. Now, each of us is going to have medical training, and today, unfortunately, Martin's feeling ill. Now, he's been feeling some chest pains. Now, that could just be down to the food rations. They aren't particularly nice, but it could be a problem with his heart, because this is one of the issues we've got to look out for. So I'm going to check Martin out, make sure his heart's working fine, and then therefore we can eliminate that problem and know it's probably just the rations.
So, all crew members would have to be medically trained?
Yeah, that'd be the issue. You'd also be wearing a bodysuit, so people back at Mission Control could actually see that your body was working fine. So that's going to be another problem with it, actually, that your bodily functions are constantly going to be monitored, so people are going to be observing you, know what's going on inside you kind of intimately, even more so than you do. But yeah, everyone on board will have to be surgically trained to some degree. In case you can imagine someone gets appendicitis up there or something like that, they can't simply die. They're going to have to be trained to deal with this.
I remember going to the Air and Space Museum in Washington and seeing, I can't remember which, Apollo 8 I think it might have been, and just seeing how tiny that capsule is. What if you want to get away from one another?
This is a problem. We've been quite generous in our spacing on board there, but this is going to be the issue. There's not going to be a space where you can just disappear off and be on your own. It's going to be really cramped inside because, as I say, launching things into space, the lifter capacity we've got, we can't take huge objects up into space. So, yeah, there's going to be an issue that you can't simply just disappear off. People will probably have to find their own little kind of nooks and crannies and ways of dealing with just being in that contained space.
I mean, this is obviously a highly theoretical idea, but, you know, solar radiation, is that a potential danger?
That's my background. That's a really big problem. You may have heard of things called coronal mass ejections or solar flares, and these are kind of huge explosions on the solar surface, and they release kind of particles and energy out into the Earth. Now, occasionally they hit the Earth and we get aurora, and that's absolutely beautiful. But if they hit our space craft with our astronauts inside, you can get radiation sickness at a lower level, and then at worst you could get instant death, and this is a real problem. And the other problem is on the surface of Mars it doesn't have a much of a magnetic field, which again would prevent particles hitting them.
Final thought, is this realistic?
It is. I would say not now, but decades it certainly is possible, and hope to see it.
Simon, thank you very much indeed for joining us and explaining all of this. And you can see the documentary, How to Put a Human on Mars, this weekend on BBC World News at the following times, and all the on the screens there, and you'll find it on the website.